thinking when you're ever comparing fractions, there's always one tool that you can always use, one means that you can always compare fractions, and that's what we call the cross multiplication algorithm. And the cross multiplication algorithm simply says that you will, let me actually label this as fraction A and fraction B. If you want to see if a fraction is greater than, less than, or equal to another fraction, you'll multiply the numerator of fraction A times the denominator of fraction B. And when you do that, you actually get 16. So then to find the other, you multiply the denominator of fraction A and the numerator of fraction B. So 5 times 3 is 15. And basically what this says is you can use the products to actually determine what the answer is, because you're saying that both of these now have equal denominators, where you have 5 times 4, so they're both in the sequence of 20ths on the number line. So this would be 16 20ths and this would be 15 20ths on the number line. Alright, so I can see that 16 is not the same as 15, so I know that they're not equal. So I know that equals out of the picture now. Now I just have to think. Let's see, greater than means to the right. So which one of these numbers, if they were on the number line, would be furthest to the right? It'd be 16. So the symbol is going to open up to the greater number. And that's why 16 is greater than 15. Alright, so that's one way to prove that 4/5 would be greater than 3/4 on the number line. Alright, so that's one tool you can use. Typically you think of tools, you think of these. This right here is called a compass. And a compass is used for drawing circles. And this is called a protractor. And this, as we all have seen many of our lives, is called a ruler right here. Alright, let's actually see how these are used. So let's use these tools strategically. If I'm trying to draw a circle, I'm going to use a compass. Alright, so let me show you how this works. As I said earlier, a compass is used to draw a circle, and a circle is simply a set of points that are the same distance from the center. So here's the center point, and all the points that I draw are going to be the same distance from that center. There we go. So I've drawn a circle, and that's the point of a compass. I've gone 360 degrees as well. Alright, let's show a protractor. A protractor is used to measure angles. So what you would do, how to use the protractor strategically, is you would take the right here, and you'd put the center of that protractor on the vertex, and make sure that the bottom line, this line right here, is lined up with the bottom ray of your angle. So here's the vertex, make sure it's there, and then also make sure that the other ray is lying within your protractor. Alright, let's see, we're starting at this 0, so I'm going to use the inside. I'm going to use the inside scale, and let's see, let's shrink this down so I can see where it falls. Alright, so I know that it's 10, 20, 20, let's see, 20, what 20 are we talking about? 23. So 23 degrees, that's what this angle measurement would be. And lastly, we have this ruler, and we always place, I want to measure the length of the red line segment. And this right here is in centimeters, and a ruler is used to measure length. Let's see, I have 5 and 1, 2, 5 and 2, let's see what these are. 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. Alright, so they're tenths. So I have 5 and 2 tenths. I could write that like this. 5 and 2 tenths. And those would be centimeters. Or I also have 52 because there are 10 in each. There are 10 millimeters in 1 centimeter. So I have 10, 20, 30, 40, 50, 1, 2. I also have 52 millimeters. 10 millimeters are in 1 centimeter. And if I think about that, there I go. There's 1 centimeter. All right. Let us also see that we can measure this in inches as well. So I just changed the unit of measurement that I was using. So let's see, I have 1 inch, 2 inches, and 1. 1 what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16ths. So I have 2 and 1/16 inches as well. And that's the symbol we use for inches if we don't want to write out the word inches. We use 2 apostrophes. And that would be inches. All right, so we see how to use those tools strategically and know the purpose for using them as well. All right, the next mathematical practice is to attend to precision. That means to be very precise, be exact. So if the problem asked me to figure out what's the diameter of this circle, given that I have a radius is just a line segment that goes from center point to any point on the circle, and I want to find the diameter. Well, I know that diameter is 2 times the radius. So if I'm trying to find the diameter, I'm just going to plug in. I know the radius equals 30 centimeters. And I'm going to do 2. There's multiplication happening between the 2 and the r. So I'm going to do 2 times 30 centimeters. And that would give me a diameter of 60. Now to be precise, I wouldn't say the diameter is 60. I'd say the diameter is 60 centimeters. And that's just what precision is about. Giving the units, being very precise. Because if you don't give units, then numbers are kind of meaningless. Next one, look for and make use of structure. All right, so it's just looking for patterns and seeing something that happens. So this is a problem about finding the different combinations that Pamela can choose from. You can read the problem on your own. But if I look at this and I'm listing the outcomes, I'm seeing CI, C-R, C-O, C-M, C-L, and then I go to the next one, B-I. I'm noticing that there's a pattern here. So it's B-R, B-C, no, B-O, B-M, and B-L. And if I notice here, that's exactly what happened. B-I, B-R, B-O, B-M, and B-L. You can see here that here are the CBs, CB, 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 CB. I'm just looking for a pattern, so it makes my life easier. And then IROML, IROML for each. And finally, looking for and expressing regularity and repeated reasoning. So just noticing that there are certain things that you can constantly apply and it makes sense across the board because mathematics is very coherent. It sticks. Principles that are given for one apply to others as well. All right. So looking at this problem right here, I see that I'm multiplying what we call in math binomials. Binomials are 2 different terms. So this is a binomial because a term is separated by addition or subtraction. So here I have one term and I have another term. So I have 2 terms, and the prefix bi means 2. The prefix tri means 3. And the prefix mono or uni means 1. All right? So here I also have another binomial because I have 2 terms, 1 term, and 2 terms. So to multiply binomials, what you would do is, this is a very common way to think about it, is you take the first term and the first term in this binomial and multiply it to get the first term in your answer. So x times x, we know this because of exponents, is x to the second power. All right, next, to find the last term of your answer, take the last term and the last term and multiply them. So I have 3 and 8. 3 times 8 is 24. So our last term is going to be positive 24. All right, and to find the middle term, what you would do is simply use rainbow multiplication. So what that means is you would draw a rainbow. So you multiply the x by 8 and the 3 by x. So x times 8 is 8x, and 3 times x is 3x. So 8x plus 3x is 11x, positive 11x. And that's how we have used that example to solve and simplify these binomials, all right, to multiply them as well. All right, so I should be able to use that same reasoning here. So let me take, and this is a really cool observation here because it saves you a whole lot of time. Let me take 4 times 2, and I get 8. Let me take the last term of the last term and multiply that. 1 times 3 is 3. I know there's one more space right here for it. All right, let's do 4 times 3 is 12, and 1 times 2 is 2, and 12 plus 2 is 14. So I'll put the 4 there and carry forward the 1, and the answer is 943. And I bet you didn't know that, but I bet now that you're going to use it, you're going to have a lot of speed